Good morning. This is Rajesh Reddy, Assistant Professor of Mathematics, Government First Aid College, Pavagada. In the third semester BCA, we have mathematics paper, that is computational numerical techniques. In the numerical analysis, we are going to find the roots of given algebraic equation. In the previous sessions, we discussed about the direct methods and iterative methods. The first iterative method and simple method is bisection method. Then we discussed Newton-Raphson method. So now we discuss in this session we discuss Newton's method of nonlinear equations. So what is Newton's method for nonlinear equations? If you consider the system of equations f of x comma y is equals to 0 and g of x comma y is equals to 0 for two unknowns x and y, treating each one is a variable, Newton's method for one variable can be applied, and the iterative formula is xi plus 1 is equals to xi minus f of xi comma yi divided by dou f of xi comma yi divided by dou x. That means partially with respect to x for the given function. And yi plus 1 is equals to yi minus f of xi comma yi divided by partial derivative of g with respect to x. xi comma xi plus 1 comma yi, where I values 0, 1, 2, 3 and so on. Using this iterative formula, we can measure the solution of the nonlinear equations. Suppose, for example, we have to find x and y for the equations. F of x comma y is equals to x square plus y minus 11 is equals to 0. And other function g of x comma y is equals to y square plus x minus 7 equals to 0. And assuming the initial approximations x naught is 3.5, y naught is minus 1.8. First we calculate x1, that is x naught plus h, comma y1, y naught plus k. Fx we measure, that means partially we differentiate given function f, that is 2x. Fy is plus 1. Gx partially with respect to x is 1. Gy, that is partially with respect to y for the given function g, that is 2y. Now we measure f of x naught comma y naught. In the given function f of x comma y, in this one we put x is equals to x naught and y is equals to y naught. We get minus 0.55. Like that, in the given function g, in the place of x we put x naught and y is equals to y naught. We get g of x naught comma y naught, that is minus 0.26. Now in the first order partial derivative dou f by dou x, again in the place of x we put x naught, y is equals to y naught. So that is equals to 2 into x value x naught 3.5, that is 7. Like that, dou f by dou y at x naught y naught is 1. Dou g divided by dou x at x naught y naught is equals to 1. Dou g divided by dou x at x naught y naught, that is minus 3.6. Finding the Jacobian. So this one is dou f divided by dou y at x is x naught y naught. X is x naught, y is equals to y naught, that one is 1. And this one is dou g divided by dou y here. At x is equals to x naught, y is equals to y naught, that is minus 3.6. Using these four first order partial derivatives, we can measure the Jacobian. That is determinant of 7, 1, 1 minus 3.6. It is nothing but minus 26.2. Then h is equals to g into f of y minus f into gy by j, Jacobian, at x naught y naught, that is 0.0855. Next, finding k. F into gx minus g into fx by j at x naught y naught. It is minus 0.485. Then x1 is equals to x naught plus h, that is 3.5. y1 is equals to y naught plus k, that is minus 1.8. So these are the first approximations to given nonlinear equations. We can measure by using Newton's method like this.